Welcome to today's explainer. Look, if you've been following the tech space lately, you're probably just drowning in buzzwords, right? Claude, Devin, autonomous agents, the list goes on and on. And honestly, when you start digging into AI agents, it's so easy to get totally lost in the terminology. But today, we're cutting through all that noise. I'm going to give you a highly practical, step-by-step builder's blueprint to completely demystify what these agents actually are, and much more importantly, how you can actually build them yourself. Okay, so here's our roadmap for this explainer. First, we'll deconstruct the agent, then weigh no code against coding frameworks, dive into multi-agent systems, establish those absolutely crucial security guardrails, evaluate performance, and finally wrap up with a concrete project roadmap. Let's get right into it. Section 1, deconstructing the AI agent. We're looking at core AI mechanics here. Now, I want to pose this question directly to you. What exactly makes an AI an agent? Think about it for a second. When you use something like ChatGPT to pull live flight prices, or you ask Amazon's Rufus to order you some organic honey, we're way beyond just a simple chat interface. Because remember, large language models have a knowledge cutoff date. If it's just a pure LLM, there is no way it should know today's flight prices or be able to actually place an order for you. So how exactly is it pulling that off? Well, the secret is in a core equation. An AI agent is a system that combines a large language model with tools, knowledge, and memory. You see, the LLM is really just the brain. To actually execute complex goals on its own, that brain needs access to external APIs, which act as its hands, its tools. It needs databases for knowledge, and it absolutely needs memory to keep track of past conversations and the steps it's already taken. It helps to think of it like this. An LLM all by itself is basically a human's bare hand. If I ask you to drive a screw into a wall using only your bare hand, you can't do it, right? You've got the brain power, but you literally lack the physical capability. But hand you a drill, and boom, suddenly you can execute that complex task. In the AI world, that drill represents tools like a checkout API or a product database. Equip that LLM with the right tools, and it transforms into an autonomous agent. And to actually use those tools effectively, the agent employs something called the REACT loop. That stands for reason and act. It works like this. When given a complex goal, the agent first reasons and plans out its approach. Then, it acts by calling a specific tool. Next, it observes the output from that tool and then refines its plan. It just keeps looping through these multi-step reasoning cycles, using its memory to track its progress until the entire task is totally complete. Now, let's clear up a massive misconception. Just because an app uses an LLM does not automatically make it an agent. Say you write a strict Python script that takes a news article, passes it to an LLM to summarize, and spits out the text. That's a workflow. The programmer is completely in charge. True agency means the LLM is autonomously deciding the control flow itself. It's the one deciding which tools to call and exactly when to call them. It's a complete game changer. Section 2, no-code tools versus code frameworks. Let's talk about choosing your path as a builder. You essentially have two main paths here. On one side, we have no-code tools like Zapier and NNN, and these are fantastic because they're incredibly accessible. You're using visual drag-and-drop interfaces to connect components without writing a single line of code. On the other side, we've got coding frameworks like LangChain or Crew AI. Naturally, these require programming chops, but they offer deep, highly customizable programmatic control over exactly how your agent behaves. Let's ground this with a concrete example using the LangChain code framework to build a shopping agent. You kick things off by providing a system prompt with detailed instructions. Then you give the LLM access to an SQLite database. That's its knowledge base about products. Next, you hand it two tools, a GetRating API and a Checkout API. Notice what you're not doing here. You aren't wiring the workflow. You just provide the tools. So if you tell it to go buy some 4.5-star organic honey, the agent autonomously queries the database, checks the ratings API, and triggers the checkout API all by itself. Pretty wild, right? Section 3, multi-agent systems and workflows. Moving into collaborative networks. Now, what happens when a problem is just too massive for one agent to handle? Well, you build a multi-agent system where specialized agents actually collaborate. For instance, you could have a product search agent that finds an item, and then it literally hands the task off to a specialized checkout agent. Or in software development, a planning agent outlines the architecture, passes it to a coding agent to write the script, which then hands it off to a review agent to test the output. It's essentially spinning up a virtual team of AI specialists. And the coolest part? These systems aren't limited to just text anymore. By leveraging underlying models like Gemini or GPT-4, we're building multimodal agents. Imagine a health insurance agent that doesn't just read plain text, but simultaneously analyzes and extracts data from images of handwritten doctor notes, audio files, and even scanned ID cards. The capabilities here are expanding at lightning speed. Section 4, implementing essential security guardrails, because we need to deploy safely. Our source material uses a pretty stark analogy here, but it's totally spot on. An agent is like a monkey with a gun. If you don't control it, it can do damage. And look, this isn't just theoretical fear-mongering. Remember when Air Canada got slapped with a lawsuit because their AI chatbot hallucinated a completely fake refund policy? They actually had to pay up. Or think about the Chipotle chatbot that was supposed to take food orders, but users somehow managed to trick it into writing software code instead. So the major risks of deploying an agent basically break down into 3 big categories. First up, you've got PII data leaks. That's your agent accidentally exposing credit card numbers or personal info. Second are out-of-scope actions, exactly like that Chipotle bot writing code instead of ordering a burrito. And third, jailbreaks. This is where hackers use clever prompt engineering, like the infamous trick of asking the AI to roleplay as a grandma who used to manage a napalm factory just to bypass safety filters and get dangerous instructions. The reality is, high agency naturally means low predictability, which kicks the door wide open for malicious users. To stop this from happening, you absolutely must implement essential security guardrails. If you're building in LangChain, you can actually set up a middleware layer that sits squarely between your agent and your database. Think of this middleware as a strict security bouncer. It's explicitly programmed to automatically mask credit card numbers and redact personal email addresses before that data ever makes its way back to the user. So even if the LLM somehow tries to output sensitive info, the middleware catches it and sanitizes it on the spot. Section 5, evaluating cost and latency. How we measure things in production. Now, evaluating traditional software is relatively straightforward because it's deterministic, but AI agents are probabilistic, meaning they might give you slightly different answers to the exact same input depending on the day. Because of that, you have to measure their performance across 3 distinct categories using frameworks like Langsmith. You need to measure functional metrics like accuracy and hallucination rates, cost metrics to ensure your token usage is optimized so you don't get a massive surprise cloud bill, and safety metrics, actively monitoring for things like toxicity and those PII leaks we just talked about. Let's actually look at how you'd use an evaluation dashboard to compare 2 different models head-to-head. Right here, we have a test comparing an open-source GPT model against a Qwen model. By checking out the P50 and P99 latency scores, which just means how fast the model returns results for the vast majority of queries, alongside semantic match scores for accuracy, you get a really clear picture. In this specific test run, the GPT OSS model proved to be faster, it was cheaper, and it even had a slightly better accuracy match. So for cost effectiveness, it's the clear winner. Section 6, your AI project roadmap. Time to start building. Look, to really internalize all these concepts, you've got to get your hands dirty and build. So based on our source material, here is a super clear 5-step project roadmap for you. Start simple. Try building a Zapier customer care agent using a no-code approach. Once you're comfortable, graduate to an N8N visual workflow using Google's Gemini. Step 3, dive into code by building that LangChain shopping agent. Step 4, challenge yourself to implement the PII middleware we covered to properly secure it. And finally, bring the whole shebang together by creating a multi-agent collaborative coding system. But as you take on these projects, keep the core lesson of the agency trade-off in mind. As you hand over more control to the LLM, giving it higher autonomy to loop, reason, and call tools on its own, its predictability naturally decreases. Giving it that control yields some absolutely incredible, powerful results, but it absolutely requires careful oversight, rock-solid guardrails, and just constant iteration. You want to start small, test your workflows thoroughly, and build up that agency over time. So, looking at that roadmap and thinking about all the tools, the memory integrations, and the guardrails we've covered today, what will be the first AI agent you build? Open up those frameworks, start messing around with the React loop, and just start building. Thanks so much for joining me on this explainer, and I'll catch you in the next one.